Our solar system is a wondrous place with a single star, our sun, and everything that orbits around it: planets, moons, asteroids, and comets. What do we know about this beautiful solar system we call home? It's part of an even larger cosmos with billions of other solar systems.
Hi, I'm Jim Green, NASA's chief scientist, and this is Gravity Assist. I'm here with Kelly Fast, the Near Earth Object Observation Program Manager in NASA's Planetary Defense Coordination Office. It's a real pleasure to have her here. I've known Kelly for a number of years, and she is a planetary astronomer. Kelly, what is a planetary astronomer?
Well, it just simply means we look at planets or solar system objects from telescopes on the ground or in space. In planetary science, we tend to go to our targets with missions, but in planetary astronomy, we look at them from afar using telescopes, so we can look at targets that we might not necessarily be at the moment.
Well, that's really important when you think about the fact that we have to scan the whole sky looking for near-Earth objects, those things that cross our orbit that may hit our Earth one day. And so there's an array of tools that you use as part of your job. Tell us a little bit about them.
Well, in the Near-Earth Object Observations Program, the idea is to find near-Earth asteroids before they find us. And so ground-based telescopes are used to survey the skies every night. To look for near-Earth asteroids and try to discover the ones that haven't been discovered before. Some telescopes in particular are the Pan-STARRS telescopes that belong to the University of Hawaii, and the Catalina Sky Survey that are part of the University of Arizona. So those are the main telescopes that provide those new discoveries.
Yeah, now when you find them, you also need to, know how big they are and maybe their spin rate and some attributes of them, whether they're iron meteorites or they're, just stonies. How do we get that kind of information?
Right. Well, that kind of information comes from other telescopes that seek to characterize these objects. And one in particular is actually a NASA telescope on the ground, NASA's Infrared Telescope Facility on Mauna Kea on the Big Island of Hawaii. And at that telescope, observations are made and spectra are taken in the infrared, the part of the spectrum that the eye can't see. But from that information, it's possible to tell something about what these asteroids are made of, what their composition is, which is important for understanding, again, what sort of hazard they might pose to Earth. And in addition, there are other telescopes, even a space telescope like NEOWISE, which is the repurposed Wide Infrared Survey Explorer. And the same observations are made from space in order to learn more about the characteristics of objects. What are they made of? What are their sizes? What are their properties? And so that, in combination with the telescopes that find them, are very powerful tools for filling out the catalog.
I want to go back and talk a little bit about that infrared telescope on Mauna Kea. We call that the IRTF. And I had a chance to be up on that mountain not too long ago. And I have to tell you, I did not know that visiting that telescope was on my bucket list until I was there. It's at 14,000 feet altitude, and it's just got a tremendous dedicated set of people supporting the observations that go on. You've been on that telescope many times. Tell us about what it's like to observe out of the IRTF.
It is a very otherworldly experience because it's like being on Mars when you're on top of that extinct volcano on the Big Island of Hawaii. And IRTF is operated for NASA by the University of Hawaii. Some amazing people who run it. And from there, it's a telescope that has a very special place in the planetary science community because it was built by NASA to support NASA's planetary programs going all the way back to the Voyager missions to Jupiter and Saturn. And so since then, that telescope has been supporting multiple missions. And being out there, it's an incredible experience, and it can be a rough experience between the altitude and the late nights and everything. But it's one of the premier places in the world for planetary astronomy, for studying planets from the ground.
Those people that work on the mountain and support those telescopes are I just really admire them. I was in a briefing not too long ago with sitting, sort of like the fly on the wall listening, and they're talking about repairing this and getting ready and moving this, it's into the focal point and something else. And here they are. I was having trouble, concentrating and trouble breathing, particularly if I moved rapidly because of that altitude is so high. And yet these people do that every day.
Yeah, it's very important to be careful. When they do travel up the mountain to work, they stop at the mid-level facility at 9,000 feet to get used to the altitude before continuing all the way to 14,000 feet. When I worked out there, I worked with a visitor instrument group from Goddard Space Flight Center. We would bring an instrument out there to put on the telescope, but it meant a lot of setup work ahead of time, and we were very careful to check each other just to make sure that we were doing the right thing, because it is possible for that altitude to affect you, and want to make sure that you check each other and you're careful. It's like, are you sure you want to go touch that high voltage wire?
Yeah, it's called altitude sickness, and sometimes your mind isn't working fast as it normally does, and you really have to think about what you're doing. So it is. I just think it's working in the extremes to make fabulous science happen, and I dearly appreciate all those that work on the mountain. Well, there's another new tool that's come up that recently begins to look down at the Earth and see infalling material. What is that telescope?
Well, it's actually an Earth science mission on the GOES-16 satellite, which is looking at the Earth. And one of the things about when we were talking earlier about planetary defense, looking for asteroids before they find us, well, there's stuff hitting the Earth all the time, and thankfully it's small material. And when you go outside, you see shooting stars. What that is really small, dust and small, very small rocks hitting the atmosphere from outside, and they make that streak in the sky. Well, it turns out on the GOES-16 satellite, there's an instrument called the Geostationary Lightning Mapper, or GLM. And it's there to detect lightning, looking down at the Earth to detect lightning. But those flashes, it turns out the meteors that travel through the atmosphere when a piece of dust or a small meteoroid or asteroid hits the atmosphere, that also creates that flash of light. And that instrument is detecting those also. And it turns out that there's valuable information that you can get from that. So this is a case where you get this bonus science from a particular instrument.
Yeah, what's really neat about that is, as I understand it, correct me if I'm not right, that nearly 100 tons of meteoric material and dust fall into the Earth's atmosphere a day.
That's true, and it's Earth is like a big vacuum cleaner, I guess, through its orbit. And again, thankfully, this is all. It sounds like a lot of material, but the Earth is big, and that all burns up. The atmosphere is an incredible protector for us, and so much of that just never even reaches the ground. It burns up in the atmosphere, creates those beautiful shooting stars, and then if there's something that's larger, it'll create one of those fireballs or bolides, something brighter, and GLM can be helpful in studying such things in order to kind of connect it back to what's the population
Correct.
of objects
Right.
out there that we need to think about.
Yeah, so as we see it come in and we can then predict where it is, we have teams of people that will go out and find debris, and then that tells us what the type of meteorite it was that came in.
We had an incredible experience recently, just a few months ago in June 2018, where an asteroid was discovered, a very small asteroid, just a few meters in size. Its designation was 2018 LA, and it was discovered 8 hours before it impacted the Earth. And once it impacted the Earth, that bolide was seen, the meteor was seen by surveillance cameras and government sensors and all, and a meteorite was recovered afterwards. And that's very important for science, to be able to not only be able to study this meteorite from space and be able to learn something about the history of the solar system, but to connect it back to an actual asteroid whose actual orbit was determined. And so that tells you more about where this came from in the first place.
As we're talking about it, it makes it seem like, well, we just see everything in the sky and we know everything that's crossing our orbit. And we see these things as the Earth sweeps up material as it moves in its orbit. But we got a surprise not too long ago. In October of last year, a asteroid was coming through our solar system that we started to observe. Tell us what we found out.
Yeah, this was very interesting, and another case of kind of bonus science that comes out of regular NASA operations. The Pan-STARRS telescope in Hawaii was doing its normal near-Earth object survey operation, scanning the sky at night looking for new asteroids, and it found one. But the motion of this one was different. It was moving quite fast, and the folks who do orbit calculation, calculated the orbit out and calculated it back and realized, wow, this thing whipped around the sun and actually came from above the plane of the solar system. So it wasn't something that was just flung around in our own solar system by Jupiter or what have you. This came from outside. And it was moving so fast that it was going to leave the solar system. And so to find something like that with that kind of motion and to be able to come to that conclusion that, this isn't one of our own asteroids, that was a very important discovery.
I mean, the concept that here, something that was created in another solar system is passing through. Man, that just really, I think, energized so many of the ground-based astronomers and our scientists that wanted to know so much more about it. And so a lot of observing started all over the place.
Right, and there was very little time because our surveys have to look at night, and this asteroid was discovered after it had passed by Earth, and it was on its way out of the solar system, and this thing was booking on its way out of the solar system. And so there was limited time to study it, but telescopes on the ground and in space were pointed at this to try to learn more about it while we could.
Now, what are some of the things that we learned from these telescopes that were then concentrated in looking solely at this object?
Well, it's difficult with asteroids because even as it's going by the Earth, it still looks like a point of light unless it's close enough to put radar on it, and this wasn't. But there are other things that you can still learn. I mean, first of all, just by measuring the positions, that will tell you about the orbit. But also looking at the light that's coming from it, you might not be able to get a picture, an image of it, but you can see how the light is changing. And this was kind of unusual because the light was changing a lot. It was getting brighter and fainter, brighter and fainter. And that's not unusual with asteroids because they tend not to always be round. And so depending on how that thing is oriented toward you, the light is going to be different. So that changing light can tell you about the shape. But this one was a little more extreme, and it appeared to be possibly even more elongated than other asteroids that have been studied in our solar system. So that was a neat discovery.
Yeah, so the light curve, the looking at that light over time and the ups and the downs that are occurring, they have models that then they go through and try to fit that. And I guess the best fit seems to be a cigar or elongated shape object.
Right. There have been some different numbers that have come out in terms of its aspect ratio, meaning like how wide is it compared to how tall it is, or its length to its width, and so maybe as much as 10-to-1, or maybe more like 5 to 6 to 1. But still something that's longer than what we've generally seen of what we can measure in our own solar system, and we still have a long ways to go in our own solar system, but it made this stand out all the more.
Yeah, so we haven't found anything in our asteroid belt or in our solar system that is more than 3-to-1 in that ratio. That's my understanding. So that's why this is just such a bizarre object, not only coming from another solar system passing through, but even its shape.
Right. And there were other properties, too, that were useful for trying to understand more about this object. One thing that was seen, unfortunately, it was a little too faint to take a spectrum of it, which really could have said more about the composition, but still color tells you something about it. And this seemed to have a reddened color, which kind of comes with space weathering, I guess, by getting bombarded by radiation in space. And it's not unlike some objects in our own outer solar system. So that color at least says something about it too.
Well, we now know that our solar wind goes out to about 120 astronomical units. That's towards the end of what we call the heliopause. So the redness of this object means that other winds from other stars are reddening it, are impacting the object, and then changing its spectrum.
Yeah, and this has been traveling through space and being irradiated for a long time, and it was showing that kind of weathering.
That's really fantastic. Well, this is the first one we've seen. Arthur C. Clarke wrote a book about an interstellar object called Rama, which also was a cigar-shaped object. But in that story, of course, it was an intelligence life spaceship. But and that's not what we're finding here. But what's really exciting about it is if this is one we've found, then are there others?
Right, because even before this object was found, and I don't know if we even mentioned that it had been given the name Oumuamua, and even before it was found, that was predicted that such objects should be passing through our solar system. People who model the formation of solar systems, this sort of thing would be predicted. Some material would be ejected. So it's not like this was a very unusual thing, but it was unusual to finally see it because we just haven't been able to do that. And so this is probably isn't the only one. It's just the one that we've seen.
Yeah, I mean, it's logical that these things are occurring. If we make material in our solar system and Jupiter and other the large planets eject them through gravitational interactions, then that must be happening from other bodies. So indeed, we should expect that. But I have to tell you, when that first came out, I was just tremendously excited. There's always something about the first, and the first one observed. Now, as we talked about, I secretly wanted everyone to call it Rama. But that didn't happen. Oumuamua is its name. How did that come about?
Well, when it was first discovered, because it was discovered in Hawaii by the Pan-STARRS telescope, and the researchers in Hawaii thought it would be a nice way to honor Hawaii by giving it a Hawaiian name, and they consulted with Hawaiian language experts there and came up with this name, which pretty much means traveler from afar arriving first, Oumuamua.
Oh,
and
cool.
So it's just a beautiful name for it, and just very, very appropriate.
It is. I've gotten used to it.
Oh.
Yeah, indeed. I've really enjoyed these kind of observations that come up, and it's not coming back into the solar system anytime soon. But how many do we expect now that we've seen this one and can actually make some basic calculations?
Well, there are folks who do that kind of modeling, and some are saying that there should be one available at all times, one inside the Earth's orbit at all times. And the telescopes, at least on the ground, can only look at night, so it can only cover so much of the sky. But the nice thing is, since this was a pathfinder, it gave an idea of what to look for. And so it might be possible to recognize this sort of thing sooner, or perhaps go into older data and look for some things that were missed. But at least now it's like it's on. It's time to it's time to watch,
get serious.
Time to get serious. Watch for them.
Well, you're right. Now that we've seen one, and of course we would dearly love to go to one of these, and this one in particular was moving so fast we'd never be able to catch it, no matter what. But maybe some of our planets, like the giant planets, have captured one. Is that a possibility?
That could happen because Jupiter certainly it holds most of the mass of the solar system besides the sun, and it affects the orbits of many things. And so it's possible that if something were to pass through, that it could capture it or change its orbit or trajectory.
Yeah, well, at one time there was a little bit of a discussion over this last year that there is a captured asteroid that Jupiter has that's actually not moving around Jupiter like everything else, but in what we call the retrograde orbit, going the other way. Maybe, just maybe, that's a captured extrasolar system asteroid that we could go interrogate.
Yeah, it's a fun thing to speculate about and to try to see, okay, what are the what ifs here?
Yeah.
So-
Well, indeed, now that we have some basic characteristics under our belt, so to speak, and we know what we can look for, I know there's a number of people that are out there trying to find something that then we can create a mission concept around and actually go out and visit it. The ability to go to one of these and actually interrogate it and look at its not only its structure, but indeed its composition, I think would tell us an enormous amount about how common solar systems are with the material that we have.
Right, and this was so hard for scientists to just kind of watch this go by and watch it race away. They wanted to find out so much more. In fact, that brings to mind how things weren't quite exactly as they seemed at first, because the people who do this sort of modeling really would have expected that this would have been an icy body, like a cometary body, as opposed to an asteroid. But no coma was seen when it was first discovered, or ever. No actual like atmosphere around it that forms when the sun heats up an icy body, and you get this atmosphere forming around it, like what you see on comets. So no coma or tail was seen. But later on, as it was continued to be observed, the motion was a little odd, and I know you were very excited about that too, because especially the whole idea of oh, it's acting like a spaceship. Well, no, it's not, but it. What was very valuable, both ground-based telescopes and the Hubble Space Telescope, by very carefully measuring this motion and seeing that it was a little off, what it indicated is that, you know what, this might actually be an icy body, because jet activity on comets, when the ice is heated and the gases are released, that can affect the motion too, like little rocket motors on there.
Mm-hmm.
And so it turns out that this asteroid that we were talking about may actually be a comet, and so that was another important discovery as as the race went on to study this
that's
object.
Right. So it's now looks like it's accelerating outward. It's being pushed in some way, and of course, the jet theory is one of the obvious ones. But as you say, there's no real obvious coma. There's no real obvious debris that it's leaving in its wake. So that makes it a mystery.
Oh, and as you said, if we had a way to send a spacecraft quickly to something like this, then wouldn't have so many of these questions.
This object's about 700 meters long, I think, is the current estimate, and it has a funny, unusual spin to it. It's like a cigar that is moving in a very not a systematic way. We call it nutating. And if it was a rubble pile, if it was made up of material, how could it even be held together? So maybe what is indeed holding it together is an icy body that is allowing it to hang in that manner.
Yes, there was a lot of discussion about, you were talking about how unusual it is this is so elongated, and so everybody was puzzling over this, because a more of a rubble pile object probably wouldn't have been able to hold itself together and rotate like that. So it was just like a big slab of material, and then how would that have formed? What was its history? But then ice adds another piece to the puzzle there, and so who knows?
Yeah, indeed. But I have to tell you, we have not seen any comets in our own solar system that have anywhere near this kind of structure, an elongated structure of 10 or 6 to 1. So once again, it's just so odd. It's just a fabulous discovery that I think will continue to hold our attention for quite a while until we find the next one.
That's why we want to see more.
That's right. Well, one of the things I always like to do is really ask you what your gravity assist was. What was the things that happened to you as you became the planetary scientist you are, that gives you that drive, that focus, that is accelerating you forward faster than Oumuamua is out of the solar system?
Oh, wow. I mean, I just have to credit the people around me, certainly. I think of one in particular, Ted Kostyuk at Goddard Space Flight Center, who I was working for after I got my master's, and I had kids, and I was doing science and being a mom and just loving it. And he said to me one day, "I want to talk to you about the future." And he encouraged me to go back to grad school, finish that PhD, and then it led to all kinds of things that I never would have expected or had planned. And so that was a major gravity assist for me.
Yeah, well, those are good and important discussions. In this field, to really accelerate the opportunities one has, you almost have to go all the way. You almost have to get that PhD and step into another world. So I'm really delighted you did, Kelly, because you've just been doing tremendous in this area, and I've been watching it from afar, so to speak, and am really excited about what you've been finding out, what you're doing, and I know you'll keep going. So I want to thank you so much for having a wonderful discussion about Oumuamua and finding near-Earth objects.
And thank you.
Well, my pleasure. Join us next time as I continue our discussions on the latest results from NASA research scientists. I'm Jim Green, and this is your Gravity Assist.